given the position of some object as a polynomial function of time, we would like to be able to take the derivative of this equation to find the corresponding equation that represents the velocity, the instantaneous velocity of the object as a function of time. So we'll do that next, but first I'd like to consider the coefficients of this polynomial equation and the units that those coefficients must have. The units on the -3, the 4, and the 9. Let's talk about why there must be hidden units here. So suppose x is measured in meters and time t is measured in seconds. Looking at our equation here, we have meters on the left-hand side. So if there's meters on the left, it must be meters on the right, so meters equals meters. Now on the right there are 3 terms. So if this term is meters, then this term has to be meters and this term has to be meters. We have to be able to add meters to meters to meters. You can't add meters to seconds or meters per second to kilograms. When you add 2 terms, their units have to be the same. So that means that this combination here, -3 times t squared, must overall have a unit of meters. Likewise, the 4 times the t must overall have units of meters, and the 9 must overall have a unit of meters. So meters plus meters plus meters gives us meters. Now, the time is measured in seconds. The time is seconds, and that gets squared here, so this is a second squared. Therefore, if this totally has to have units of meters, and time squared is seconds squared, then there must be some missing unit right there attached to the -3 that we didn't write down. Likewise, if this time is seconds, but overall this has to be meters per second, there must be a hidden unit there attached to the 4, and there must be a hidden unit here attached to the 9. So can we work out what those hidden units must be? So here's another way of expressing that equation just in terms of the units. Meters equals some unknown unit on the 3 times seconds squared plus some unknown unit on the 4 times seconds plus some unknown unit on the 9. All right, well, let's think of a mini equation here. If we know that overall this has to be meters, that means meters must equal the unknown unit times seconds squared. And this, on this term, meters must equal the unknown unit times seconds, and here meters must equal the unknown unit. Oh, okay, so on the last term, the unknown unit must be meters, so this is 9 meters here, actually. Must be a 9 meters right there. But on these two, here we could just look at this equation and divide both sides by meters squared. Here we can look at this equation and divide both sides by seconds. Oh, sorry, I said that wrong. Here we can look at this equation and divide both sides by seconds squared. Here, look at both sides and, here divide both sides by seconds to get us this. The unknown unit here must be meters divided by seconds squared. And the unknown unit here must be meters divided by seconds. So attached to the -3 here, there must be a meters per second squared. And attached to the 4 here, there must have been a meters per second. Let's rewrite all that to show that there were hidden units in our equation. This actually was x of t equals -3 meters per second squared times the time squared, and 4 meters per second and 9 meters. The coefficients have units on them. That's a general feature of the physics equations we'll be dealing with. Numbers that show up in our equations typically have units. And normally we don't write the units in just to save time and writing, but they are there. And it's important to be able to figure out what those units are under certain circumstances. So when we take the derivative of this equation next, we'll see the significance of the units attached to our coefficients. So just to wrap up, let's sort of check our work. If this is seconds squared times meters per second squared, time is in seconds, and that gets squared, then those cancel out, leaving us with meters on this term. This is 4 meters per second times time in seconds. Seconds cancels out, gives us meters. And so indeed we do have meters plus meters plus meters equals meters.